Today we're gonna talk about a data platform data solution that we've built and helped a client with. But other times it's running Kubernetes, running containers, and all the other crazy stuff we can do on the cloud these days. For people coming more from the software side of things, you could sort of compare what they had built with a monolithic application. And in a database architecture, you have different teams in different domains that do their own thing with the data.
Hi everyone, we are back with another episode of our Azure On Air podcast. My name's Lex, and I will be your host for today's session. With us today we have Erwin Stall. Erwin works as an Azure architect for Xpirit, which is a Dutch IT consultancy company. Today he will talk about architecture modern data platform on Azure. So welcome to the podcast again, Erwin. Before we move on to the main topic of the podcast, can you maybe introduce yourself a little bit?
Yeah, sure. So hi, thanks for having me. My name is Erwin Stall. As you mentioned, I'm an Azure architect for a consultancy company in the Netherlands called Xpirit, and I mainly help customers build their solutions on Azure. So I help them with figuring out how to run their workloads in a secure manner and cost-effective manner, and what we implement and what I help customers with different every time. So today we're gonna talk about a data platform data solution that we've built and helped a client with. But other times it's running Kubernetes, running containers, and all the other crazy stuff we can do on the cloud these days. So I'm from the Netherlands. I live in a beautiful town called Assen. I have a wife, 2 kids, third one on the way. So yeah, lots of fun.
Okay, very good. Yeah, let's just dive into your use case, right? So you mentioned already that you have been at a customer where they had a data platform, but that was not very optimized. That platform. So probably that was the reason why you and your team came in to make all the improvements. Can you elaborate a little bit on how that all went?
Yeah, sure. So it was about a year and a half ago, I guess, that we came in. And first, a few colleagues of mine of our company came in to do an assessment on their current data platform to see. The company asked us to do the assessment because they had a few problems with the current platform. The platform was built as one gigantic data platform, which is something that we see at other customers as well. And for people coming more from the software side of things, you could sort of compare what they had built with a monolithic application. So just a gigantic application that you would deploy at once. That was also a bit what they have been doing here with their data platform, with all the consequences that come with that. So just as with when you deploy a monolithic application, when you deploy a monolithic data platform, it also becomes quite hard to make changes to it, to have multiple people work on that platform at the same time, to properly do automation, do isolation, security, a bit of governance. All those things become kind of hard to do on the platform. So while doing the assessment, the colleagues of mine looked at the platform and found all these things. So we suggested them to build something new and start from the ground up, and see if we can actually improve and build a better platform for it. Yeah, so that's where we came from.
Okay, but that's huge, right? And these, just like you said, starting from the ground up. So you just started with setting up a new platform in Azure, and then move all solutions to the new platform, something like that.
In short, that's what we did. We obviously thought about how can we actually build a new platform and build something that will last for at least the coming decade or something. How can we actually create a platform that will help them in their journey? And so what we did is, while we were building or actually thinking about this new data platform, the company had also just implemented their landing zones on Azure. So this data platform obviously isn't the only thing that lands on the platform and needs to run in Azure. There's all sorts of other applications that also need to run there. So for those who don't know, the Azure landing zones is basically a setup in Azure in which you have a central piece in which you ensure and build decentral stuff. So connectivity to on-prem, firewalling, VPNs, all those kind of things you do in a central place. And then around that central place, you deploy these landing zones, which are basically just subscriptions in Azure, in which then workload teams can actually do their thing, deploy their infrastructure, run their applications, etc., etc. So we took that architecture and started building upon that architecture. So that means that we obviously still have a place where we need to store the data, and we can talk about how we do that in a bit. But we have a central place in which we store the data, and then every team that needs to do something with the data can actually get their own landing zone, their own spoke, so to say, in which they can do their thing. So instead of having this gigantic piece of infrastructure, we give every team that needs to do something with the data, we give them their own bit of infrastructure, their own subscription with their own services to run their thing. And depending on what they need to do, what's their use case, they might get a different implementation of that spoke.
Yeah. So all the data is stored centrally, but need all different implementations and solutions. They could connect via the spokes, to the centralized hub.
Yeah, and so I guess that's an interesting decision that we made to still have a central data store, because they also used to have a central data store, and
Sure.
that lacked a few features. That also was a problem. So at the other end of the spectrum, you could say that you could also do like you do in microservices, for example. You do distribution, right? You distribute your application in multiple microservices, which all have their own data store. And there's also something like that in the data world, which we don't call the data mesh, a data mesh architecture. And in the data mesh architecture, you have different teams in different domains that do their own thing with the data, and also then have their own storage. They store their own data. They are managing their own data, and others can use it. But also in that model, and we found it at other clients as well. Also in that model, there's a few problems with that approach, because if the data is everywhere and every domain, every team can manage their own data, that's also a bit of can also lead to problems, like how are we gonna do governance on that
Accessibility.
data?
Yeah.
And what you then see is what you also see with microservices is that one team says, oh, that's cool, I can do my own thing, so let's do .NET and let's store my data in a SQL database. And then another team comes around and says, oh, but I'm gonna do Java, I'm gonna do Python, and I'm gonna store my data in Cosmos or Postgres or whatever.
Yeah.
So you see that all these teams can actually choose to do different data formats and different systems or whatever. So interconnecting there is a real challenge. So we decided to not do that and still go with a central data store, which we as a central team govern and can put a bit of rules on top of, but still have the teams that use the data do that in their own isolated environment, where they more or less get to pick the tools that they need for their battle, so to say, to do what they need to do.
Yeah. No, understandable. Yeah, I mean, of course, all the flexibility, that you can provide via the spokes, of course, that's very interesting. But just like you said, from a governance perspective, you have challenges. Accessibility will be hard because of all those different data stores that you have. In the end, it's a strategic choice that you need to make, right? Where you want to provide all the flexibility, or just have some limitation for the teams. By just saying, okay, well, we are going to do everything stored centrally. In an Azure Data Lake, based on specific technology. So no other.
it was a well balanced choice between that's kind of what you always need to do, right? When you architect something in Azure, it's always a well balanced choice between how much freedom are we gonna give a team to do their work in an autonomous way, but we obviously also need some governance and some security, especially when we talk about data and having a single data lake in which we store all the data the company owns. Which might be financial data, which might be weather data, which might be, I don't know, images, all sorts of things. So that's obviously the crown jewels of your company, right? So you wanna put something in place to to protect that and to make sure that's governed and well looked after.
Yeah.
And
Yeah.
and here this company this works really well. And to talk a bit more about the consumers that we have in such a data platform, you see all these different use cases for data, at least in this company. So there's a few teams that do the stuff that everyone thinks of first, which is reporting. Like when we talk about data, everyone talks about reporting and using Power BI and those kind of things to come with financial results and those kind of things. So there's obviously teams within the organization that need to do that need to access all the data to and combine the data to come with useful dashboards and reports. But it's also totally different use cases like machine learning, for example. Everyone is talking about AI these days, obviously, but to make proper use of AI on your data, you first need to ensure that your data is actually useful. You can't do AI on raw data. You first need to make something useful out of the data and then build a model using machine learning and feed that to your AI instance in Azure, for example. So we have all these different use cases, all the different teams that need to do something with this data. And what we came up with is that we have this model of spokes. So we have the central data store, and then around that central data store, there's all these teams that do specific use cases on that. And what we did is we automated the whole infrastructure provisioning here. So we use Terraform to do that. And a team can now request a new spoke on the platform, and they can say, all right, so this is what we're gonna do. We need to do data ingestion. We need to ingest data into the platform, or we need to do data analytics, or we need to do data transformation. I mean, raw data is nice, but you obviously mostly want to do something with the data, make it more meaningful, and then write it back to the data store. So that's transformation. So there's all these different use cases, and when a team requests a new part in the platform, they can choose what use case they have, and then we deploy the infrastructure for that specific use case. So sometimes that is a data factory, depending on if they want to do simple ingestions. Sometimes that's Databricks, if they need to do transformations or more complicated ingestions, for example. But we can also deploy Machine Learning Studio if they are going to do machine learning stuff with that particular data. And we deployed it in their own subscription, their own environment, where only they have permissions to access that particular environment, so that no one actually can interfere with what they are doing, and we can ensure that they have access to the proper data and those kind of things.
Yeah. So again, still you have all the data in a centralized way, but still you have the flexibility. Each team has the flexibility to make their own plans, to plan their own deployments without any dependencies to the other teams, who are now working in different spokes.
Yep. Yeah, and what they also get to do is not each team is equal in the knowledge and know-how that they have, and so we see that some teams are really professional in what they do. And so, for example, when a team needs to do data transformations, some teams can do that, need simple transformations, and don't really have the knowledge to go deep. So we give them the tool dbt, which is it's a SaaS tool that you can actually buy, and then and we enable a dbt to connect into our platform, and they can use dbt to do the simple transformations. But if a team is more into needs to do more advanced stuff, really go write SQL or Spark jobs, those kind of things, then we can actually deliver them Databricks, for example, so that they can choose the tool that fits with what they need to do. And the same goes on the ingestion side of things. You can use Data Factory to ingest your data, which is more of a bit of a, for those who don't know it, more of a bit of a UI tool. Allows you to do drag and dropping and then do ingestion from source to destination. But it also has its limitations in how far you can go and how easy it is to do complex stuff. So there goes the same. If they need to do complex ingestions, then they can also go to Databricks. But quite recently, we had a team that for which it was easier to just do it with code. So we can also deploy Azure Functions and have you do your ingestions on top of Azure Functions, for example.
Yeah.
And teams can just request that type of spoke and say, I want to have this particular service or not this one. So we don't just deploy everything, because that would be also a bit of expensive, right? Depending on what we need to deploy. So they really get to pick and choose what they what fits with their team.
Yeah, true. Yeah, true. Yeah, in the end, it all depends on the amount of the workload, and just like you said, the complexity, right? Because different solutions are available. Yes, that's always the balance to find the right solution, of course. Technology isn't necessarily a deal breaker, but at least you still need to choose the right and most cost effective nowadays, of course, technologies. To properly process all
it needs to fit with the team and the use case, and also the knowledge of the team and those kind of things. So there's so much into play here.
Nice. What else is there? There was also a question about Microsoft Fabric. Before we have done an episode about Microsoft Fabric. What do you think? What's your take on how Microsoft Fabric compares to the solution that you have developed and a platform that you've used underneath?
Yeah, that's actually an interesting one. We obviously looked at Microsoft Fabric when it came out, which was just quite recently, right? Some of us were actually aware, being in the MVP program, etc., that was coming. So it was interesting to see that we've just built a platform, and which took us a while, obviously, to properly build a platform and to enable all these self-service features and whatever. And then something like Microsoft Fabric comes out. Which probably happened to a lot of people, right? You build something on Azure which didn't exist yet. And you need more fun stuff than what's available out of the box, and then you're done. And like a month later, Microsoft announces this big product, and you're like, okay.
Okay.
But
thanks for that.
But when we, I think we are still in a very good place here. What's interesting is that if you look at Fabric, then Microsoft also made the choice to create a central data store, right? They call it one egg, the sort of OneDrive, but then for data stuff. So it's interesting to see that they also made the same decision as we did, creating a central data storage and not do a decentralized thing. So that obviously was a good choice. Then again, I think when Microsoft does the same. And we also actually made the same choice in how we store the data. So Microsoft also made the choice to go for the open source format Parquet to store the data in the storage. We also made the same decision. So that's actually kind of similar to what they've done there. But on other things, you do see a few differences. So one of the things that we see is that if you want to do data ingestions in Microsoft Fabric, for example, then you mostly have to do that in Data Factory within Fabric. And one of the reasons for that is that much of the other products that are available in Fabric don't really support deep network connectivity yet into your Azure environment. So that means is if you want to do ingestions or just analytics, for example, on data that is not available in your data store within Fabric, it's really hard to get it out of your stores in Azure in a secure way, at least. There is gonna come And yeah, so there is gonna come more connectivity options to directly connect to SQL databases and whatever from the different products within Fabric, but it's not there yet. It's probably gonna come. So that makes that it's harder for us to use that product, because then we would have to do all data ingestion, for example, with Data Factory, and we just made a deliberate decision not to do that because it simply doesn't fit all use cases, at least not the ones that we have. So there's a difference there, and obviously Fabric is a very new product, so it might come. It might be the next month, right? We know it's on the roadmap. You never know, and so it's gonna come. And another difference that we see of actually a feature lacking in Fabric for now, and again it's also on the roadmap I saw, is the proper support for doing CI/CD. So I mean, like we do in software and infrastructure, if you build your infrastructure, build your software, you want to have a CI/CD pipeline to actually build and deploy that across different environments. And that's also something that we've heavily built into our platform to facilitate and ensure that people don't start doing things with their hands, manual stuff, manually building data pipelines, etc.
Yeah.
We don't want it anymore. It's almost 2024. So we ensure that within our platform you can actually do that in a proper manner. And these features are also a bit lacking, at least for now, in Fabric. Yeah. And so there's still a few reasons, and also if you look at what Databricks can do, not all of the features that you find in Databricks today are available in Fabric. So there's a lot of different, and then you get into more of in the details. But I would say that the network integration and also the CI/CD stuff are really valid reasons for us to at least not move, at least not just yet. Yeah, but the good thing is that because of the choices that we made, and some of the choices are reflected in Fabric, because of some of the choices that we did make, I would anticipate that it's actually quite easy to do a switch, and to actually move to Fabric if we wanted to.
Yeah. Yeah. Nice. Yeah. This just happens, right? I mean, those products just keep on coming, and sometimes it's just too early, and the world keeps on spinning, so you can't wait. For a product to be mature enough to start using it, right? There's ways of time.
I mean, I do know a few businesses who have already moved to Fabric, simply because for them it did work, and then having this unified SaaS solution in which everything is just available and works out of the box, that's great, right? Because we had to do a lot of plumbing underneath to actually hook up all the services together and make it work, right? And make it secure and make it go over private networking and whatever. That was quite a lot of work, and so if it fits your use case, it's obviously a very great product, and I would definitely then move to Fabric. But it just doesn't fit all scenarios yet.
No, it's not there yet indeed. Yeah. You were also telling about the teams. So probably those are the teams on the spokes that they were provided with self-service tools. What's the kind of tools that that this is about? Is that for triggering pipelines, maintenance, that kind of stuff? Or is also design?
There's a few things that teams can do on our platform, and one of the most obviously important things I would say is that they can actually automatically request these new spokes. So if a new team comes up and they decide that they are gonna move to our platform, and we now saw that a few times, because in the beginning we talked a bit about the migration, right, from the old platform to the new platform. So what we've seen now for a few times is that teams want to move to the new platform, and so they request this spoke type with us. So let's say a team needs to do analytics workload, so they request an analytics spoke. They simply fill in a form and make a pull request on our repository, in which they fill in some stuff, and then some pipeline get triggered, and their new environment starts to get provisioned in Azure. which for some services that we need to deploy actually takes a while. But so a new spoke actually gets provisioned out of the box, mostly automatically for them, including permissions, including connectivity to the central data store, and all those kind of things. So that's one of the things that we enable them to do. And we also have those type of things, being able to go to a repository, do a pull request if you need something new or need something changed, and then we simply approve that as a central team, and stuff gets running for them. And we do that on the more of the infrastructure layer, you could say, to actually get them some infrastructure. But we also do that in ingestion pipelines, for example. So we as a central team, we manage the ingestion of some of the data. Not all the data. Teams can also do that themselves, but some of the ingestion is done by a central team. But we don't simply ingest all the data. We mostly ingest data that's actually needed in a platform. But if someone needs additional data that we haven't ingested yet, then they can simply go again to a repository, do a pull request on that ingestion flow, and actually add the data that they need. So they don't have to go into some ticketing system and request that from us, and we need to plan it and whatever, and it needs to fit on a sprint and all those things. They can just go into a repository and do a pull request, and we do a bit of checking on that. Some checks go automatically, some checks need to be done manually, and those are the things we really try to leverage to give them a lot of freedom in their work, and make sure that they can do most of the stuff themselves through pull request or automatic forms, etc., instead of having to go through tickets and those kind of things.
Yeah, this also exactly one of the big advantages that you now have with that hub and spoke model, right? I mean, with that previous monolithic system, I mean, there were so many dependencies. So if you accidentally hit the wrong button, things might break, right? So yeah, by having everything kind of loosely coupled or at least separated, also the level of stability of the complete solution is much better than just having to maintain a complete monolithic solution.
Yep. Yeah, and that goes on multiple layers, right? That's on the infrastructure. You obviously, if you run a pipeline, you need a bit of compute, and by having your own isolated environment, it's your compute.
Yeah.
So no one else runs their pipelines on your compute, which might slow down your pipelines.
Yeah.
So
Yeah.
that's a bit of freedom again. It also allows us to very clearly state what your work actually costs. So if teams do a lot of transformations and might not be doing them optimal, for example, then they pay for the compute. So it's very easy to see where the money is actually going to, and it also is a lot easier in terms of isolation, in terms of security, for example, and making sure that people don't accidentally change each other's data pipelines or even each other's data, those kind of things. Yeah, really helps with those stuff as well. Yeah.
No, that's one of the other questions I was interested in. How are you setting things up financially indeed, and make sure that all the owners get the right Azure bills for the projects that they are involved in. But indeed, that as well is covered.
Yeah, that's actually quite easy in this model, since every team gets its own spoke or more than one spoke if they do different use cases, and those are in Azure simply subscriptions, and subscriptions are a very easy way of grouping the cost. It's a cost unit. Yeah, it's probably the most easiest cost units we have anyway. And one thing is that the model that we now do implement tends to be a bit more expensive than when you do go for a central monolithic model, because there's simply a bit more overhead, right, in running all these services. It's not that much, since most of the stuff in Azure you pay per second, etc. But there are a few services that we do run that you pay for 24/7 virtual machines, for example, right? So it's a bit more it costs a bit more than we would have a central environment, but we happily pay a bit more for for all the freedom that we do get.
Yeah, that's the thing, right? You have more free, just like you said, more freedom, more flexibility. And in the end, you might still save some money if you know that those resources are long-term resources. You can still maybe make some money with purchase and reservations, for example, right? And
Yep.
maybe do some
Yeah.
life cycling.
Yeah, definitely, and especially with the changes that Microsoft made in the reservations that you currently can do for VMs. In the old days, you had to make a reservation on that specific VM, but now you can make a reservation for a group, etc.
Yeah.
Yeah. So that makes it interesting, and we still can do a little bit more in terms of build a bit of own automation to properly scale down VMs or shut
Yeah.
down VMs. I mean, for a lot of pipelines, data pipelines, for example, you know that they will run during the night, for example. So during the day we can scale down.
Yeah.
So there's still a few optimization that we can make there,
I think.
and yet the other thing is that if you look at cost, it's always hard to make a business case in the sense that the Azure bill might actually go a bit up in this model, but the engineers who work on the platform actually get to do their work much quicker than they were
Exactly.
able to do
More
in the
efficient.
past.
Yeah.
Far more efficient because of how we've built the platform. It's always a bit hard to put that into a number
True.
and to compare, but yeah.
Yeah, true.
People,
Yeah.
at least, which is also very important, I guess. People are much more happier to work on this platform than on the previous one. So
Yeah,
definitely feels
that's
good.
what we're here for. Yeah, yeah. We want to bring great solutions to our customers, right? And if that works out, well, yeah, then you've done a good job. And how about stuff like monitoring those pipelines? Is that are you using Azure tooling for that, or have you developed own tooling, or how does that work?
To trigger a pipeline, you mean?
Not necessarily trigger, but also understand whether they are processed correctly, whether they are triggered indeed anyway, but also if they have been processed, correctly and successfully.
Right. Yep. Right. Yeah. So pipelines are actually triggered from different products and for different reasons. So some pipelines trigger on a nightly schedule because we simply need to do that job nightly. Some pipelines are triggered on a particular event, and when a pipeline has run, we verify. That it has run correctly with tooling. So there's basic alerting, etc., in the Azure platform itself. So if you look at Data Factory, there's simple alerting if your pipeline actually succeeded or not, and the same goes for all the other Azure tools that are built in. But we also use different SaaS products to do a bit of data quality and look at data pipelines. And we recently have implemented a new product to both do data quality but also do data lineage, for example. So so for those who don't know what lineage is, imagine you have a Power BI dashboard, and that Power BI dashboard shows a number, your net revenue, the number of things sold, whatever. Then the data lineage and this tool helps us to figure out where that number actually comes from. What is the source from which database was that number extracted, and what process might have changed that number in the way from source to your Power BI dashboard. I mean, it might have gone through different transformations, etc. So the tool helps us to get insights into where do the data come from, and where was it transformed, and all those kind of things. And something that we also started with recently is within that same tool also build up a catalog on the data that we actually have. I mean, the technology is great in Azure and building your pipelines or whatever, but if no one can actually find your data
True.
and actually can see what data is in your platform, then it's not going to work. And so people need to be able to find the data, but people also need to be able to figure out what does that data mean, because a particular field in a particular database might mean something different for you than it means for
Yeah,
me. I
that's
might
for
have a
everybody
different
else.
interpretation Yeah.
Right.
So it's also very important to get some metadata around the data to explain what the data actually is. Yeah.
Yeah.
Yeah. So we also implement and that is something that area is a bit lacking in Azure, or simply there's some stuff in Fabric actually on data lineage and data quality, but not that much yet. So we have a SaaS product that we use to do those kind of things.
Fabric, yeah, it will just come as well, right? It's just a matter of, evolution, and then that kind of capabilities will also be available. Yeah,
Yeah. There's already some stuff in Fabric out of the box. But you sometimes need to do a bit of customization on that process, and then it is lacking a bit in that area. But like we said earlier, it's a very new product, so that's gonna come for sure. Yeah.
Yeah. Nice. Thank you so much for being with us.
Thank you for having me.
Then I think that's it. And your audience, thanks for being with us as well. And we hope to meet you in the next one.
Cove.co